Hey everybody. Today we're computing some inverse functions. Your intuition should be that an inverse function reverses the inputs and outputs from your original function. It flips the x and y values. When you compute an inverse, you're just applying that idea algebraically. So if you're starting with y equals f of x, you're literally taking out the x's and putting in y's, taking out the y and putting in an x. Then you just try and solve for y. If you can do that, if you get a function back, it's going to be the inverse, f inverse of x. So it's a simple process. As I've got it written here, just 2 steps. But of course, the algebra of actually solving for y in that second step can get pretty hairy. Let's work through a couple of examples. We'll start with an easier one, f of x equals x cubed plus 5. So the left-hand side here is like your y equals x cubed plus 5. Take that out, replace it with x. Replace the x cubed with y cubed on the right-hand side. Now we need to solve this for y. So I'm going to subtract 5 from both sides. And while I'm at it here, I'm going to reverse the sides of the equation. I'd like to have y on the left-hand side when I'm done. Now I just need to take the cube root of both sides to undo that third power. Overall, y equals the cube root of x minus 5 should be our inverse function. We can verify that by checking the cancellation property. We want to do f of f inverse of x. So if I take f inverse, cube root of x minus 5, and plug it into f, that cube is going to undo the cube root. And then the minus 5 and the plus 5 are going to cancel. I'm just left with x. Now, of course, we should also check that f inverse of f of x is x, but I'm not going to go through that right here. You should do that on your own. Okay, let's do a harder example. Compute the inverse of y equals 2x minus 3 over 5 minus x. The first step is always the same, just reverse the x's and y's. Now we need to solve this for y. So my strategy is going to be to first of all get rid of the fractions by multiplying both sides by 5 minus y. And then I'm going to try and move everything with a y to one side, everything without a y to the other, and hope that I can factor out and divide. Let me show you what I mean. First, clear out the fractions, and then distribute. I've got 5x minus xy equals 2y minus 3. Now, let's get everything with a y on the left-hand side and everything without a y on the right. Great. Now I can factor out a y from the left. I'm going to be left with negative 2 minus x. While I'm at it, by the way, I'm going to multiply this whole equation by negative 1 so that not everything is negative. Instead, everything's going to be positive. So then when I'm factoring out the y, I'm left with 2 plus x. And of course, on the right-hand side, the signs have all changed, so I've got 5x plus 3. Now, I can just divide through by 2 plus x to get the inverse function, y equals 5x plus 3 over 2 plus x. By the way, notice that the domain of the inverse function is all real numbers except x equals negative 2. It's just a rational function, so the domain is every number that doesn't make the denominator 0. Inverse functions reverse domains and ranges, so that tells us that the range of the original function was all real numbers except negative 2. I don't think that's obvious when we look at the original equation for f of x. Let's check one of the cancellation properties here too. Let's check that f inverse of f of x is x, when f of x is 2x minus 3 over 5 minus x, and f inverse of x is 5x plus 3 over 2 plus x. So I'm taking that formula for f and plugging it into f inverse. That means, looking at the formula for f inverse, wherever I see an x, I need to plug in 2x minus 3 over 5 minus x. So I have this ugly compound fraction. No fun. My first priority is to make it so I don't have fractions inside of fractions anymore. I'm going to multiply the top and bottom both by 5 minus x. And that'll make it so that I don't have fractions inside of fractions anymore. For example, in the numerator, when I multiply by 5 minus x, I'm going to multiply 5 minus x by both of those terms. In the first term, it just clears out the denominator, and I get 5 times 2x minus 3. In the second term, multiplying by 5 minus x is just 3 times 5 minus x. I do the same thing on the denominator. Now, I'm just going to simplify a little bit. I multiply the 5 times 2x minus 3, 3 times 5 minus x, and do similar distributions on the bottom. Combining some like terms, I get 7x over 7, and of course the 7's just cancel, and I'm left with x. So the cancellation property here holds. F inverse of f of x is x, just like we would hope. I really do encourage you to check the other cancellation property yourself for practice. That is, check that f of f inverse of x is just x.